here once again we have to see this one. So what is our target here? Simplification of electric circuit. So I hope live is going on. Thank you people who joining our session. So let's see guys here, before entering to this simplification of electric circuit, first of all we know about resistors in series. This is very important. So resistors in series. So resistors in series are very important guys actually. So resistor series, how to find out? Very simple. So we have to connect like this. Let us say R1 is connecting and R2 is connecting. So this is point A, this is point B. So what is R equivalent? So R equivalent is equal to R1 plus R2. Simple, we had the resistance values, that's it. So nothing but that is in resistance series. So let's say an example. Let's say an example. So this is 2 ohms, this is 4 ohms. This is 2 ohms and 4 ohms. So now I want R equivalent. So how to find out R equivalent? So R equivalent is equal to, we have formula with us, R1 plus R2. So what you get? 2 plus 4. How much you get? 6 ohms. So 6 ohms. So this is in which guys? Series. Now I want to connect this one with the parallel. So what you get? So this is R1 and I have to take another resistance R2. Now I am taking another resistance R2 guys here. So this is R2. So I want to find out equivalent resistance. So how do I have to find out equivalent resistance? So R equivalent is equal to R1 R2 by R1 plus R2. So very important formula. So direct formula. So I am telling direct formula. R equivalent is equal to R1 plus R2. So another knowledge is required is that, so let's say an example, same example have to quote it here. So let's say guys here, so this is the one is 2 ohms and this is the one is 4 ohms, 4 ohms, and let us say have to connect it with the 5 volts battery. So now what you get guys, this is 2 and 4 ohm direct formula. R equivalent is equal to 2 into 4 by, so 2 into 4 means 8, 8 by 6 ohms. So this is the value you have to get for resistance in parallel. So resistance in parallel, we have to get that value. So this knowledge is for simplification of electric circuit, and also we need a Kirchhoff laws knowledge also required. So Kirchhoff laws knowledge also required. Let's see that knowledge. So let us say an example. I have to take one resistance and one battery here, and I take better. I have to take a line here. I take a battery. So this is what guys, V1 and current is I, and this is resistance. Let us say R is the resistance. Point A, this is point A guys, this is point B. So current is moving from A to B. Current is moving from A to B. So I want to implement Kirchhoff first law and second law. So Kirchhoff first law and second law I want to implement. So when you have to implement Kirchhoff first law and second law, so A and B. So let's see guys here, this is VA and current is moving in this direction. So this is on plus and minus. Where I have to stop? I stopped at negative. So what is the value you have to take? Minus you have to take. Minus E1. And how much drop is happened here? How much drop is happened? So I into R voltage drop is happened. So which is in same direction. So I am moving same direction. The current also moving with my direction only. So finally what you get? Minus IR we have to get. So minus IR is equal to R to stop at VB. So I want to VA minus VB now. So I want to, what is the potential difference between A and B? So what you have to do? VA minus VB is equal to VA minus VB is equal to E1 plus IR. So VA minus VB guys, what? VA minus VB is equal to V. V is equal to equal to E1 plus IR. E1 plus IR. So this is the way we have to implement Kirchhoff loop law. I want to implement Kirchhoff loop law very simple manner. Very simple manner. This is the way we have to implement. V is equal to E1 plus IR. E1 plus IR. So let's see guys here. Let's see one of the example I am quoting. Let's see guys, one of the example I quoted. So what is the example? V is equal to V1 plus IR. This is the Kirchhoff laws. So now I want to take one. People are understood. So let us say I am taking one resistor, 2 ohm resistors, which is connected to 4 ohm resistors, and I take another resistance, 6 ohms resistor I take. So once again which is connected to a 4 ohm resistor. So the point is A and point is B. So the point A and B is there. So I want to calculate equivalent resistance between A and B. So how to calculate equivalent resistance between A and B? So let's see guys here, same model. So first what you have to do, very simple technique, what you have to do. First everybody do the current division first. So what is the current division here? So let us say the current is, we have connected a battery. Assume that assume that we have to connected a battery. So imagination battery we have to connect it here. So when you have to connect the imagination battery, so current is flowing here. I is the current flowing. Now a branch is there here, branch. So this is called what guys? I1. This is, let us say, I2 current. So two current division is this point. Finally reach to this point. So how much current you get once again? So according to KCL, I is equal to I2, I1 plus I2. Now reverse. So I1 plus I2 is equal to what you get guys? Total current you get I. So the current here is that I. Current is that I. So comes to this diagram, what you notice? What you notice? So these two resistance, 4 ohms and 6 ohms have different currents. 2 ohms and 4 ohms have same current. So when there is a different current is there in the circuit, generally those resistance are connected in parallel. Very simple. So according to that, first we have to simplify this one. 4 ohm and 6 ohm we have to simplify. So what is the formula for R equivalent? So R equivalent is equal to 4 into 6 by 4 plus 6. 4 into 6 by 4 plus 6. 4 into 6 how much guys? 24. 24 by 4 plus 6 10. So what do you have to get? 2.4 ohms I get. Next one is that now this is actual diagram. Now I have to turn this diagram into like this. Let's see guys here. Now let's say this is point A. Point A having 2 ohms, and this is also one resistor. That is which resistors? 2.4 ohms resistor. 2.4 ohms resistor. Next what resistor will be there? 4 ohm resistor. 4 ohms resistor which is connected to B. Which is connected to B. Now what is the current here guys? This is I. This is also I. And this is also I. So current is not changing. So when current is not changing, what is the meaning of it? So the resistors are connected in series. So just now I told you what is the series formula. So R equivalent I want. So R equivalent is equal to 2 plus 2.4 plus 4 is equal to how much you get? 8.4 ohms you get. So this is the way we have to generally simple circuit. I am discussing about a simple circuit now. So when you are taking the simple circuit, what will happen? The resultant of that. So 8.4 ohms you get actually. So let's say a bigger circuit. How to tackle a bigger circuit? How to tackle a bigger circuit? So let's see guys here. I want to tackle a bigger circuit. So what do you have to do? What you have to do when you're talking about bigger circuit? What we have to do? Let's see guys here. So let us say, so this is a battery and this is a resistance, and this is one of the resistance, and we have another resistance here, and this is having a resistance, and we have another battery, and we have a resistance here. So now how to break down this one? So let us say guys here, this is R1, this is R2, this is R3, R4, R5. So we have 5 resistors. Let us say each of having 1 ohm, 2 ohm, 3 ohm, 2 ohm, R5 is equal to 5 ohm, R4 is equal to 4 ohm. So this is the circuit. So this having a potential of 5 volts, this is having a potential of 10 volts, that is EMF. EMF we having 10 volts and 5 volts. Now I want to break this circuit. Once again, same logic you have to apply. Let us say take any battery. Suppose I am taking this battery. I am starting from here. Starting from here, let us say B, and this is C, and this is D, and this is E, and this is F, guys. So this is the circuit I want to break down. So very simple. So let's say, guys, here, suppose this battery is not there. Assume this 10 volts battery is not there. We are assume like this. So once again, I redraw this diagram. Take any battery, or which no issue. So this is 1 ohm resistor, and which is connected to 2 ohm resistor, and this is connected to 3 ohm resistors, and we are assumed that battery is absent, and this is 4 ohm resistor, and this is 5 ohm resistor. So 5 ohm resistors. Now we are connected to a battery. Now we are connected to a battery. So everybody knows now. So generally when you're dealing with electric circuit simplifications, generally what you have to do, simple logic what you have to do. So the logic is very clear, guys. So this is plus and minus. So current I, when come to here, what will happen? So there is a division is happened. So the division is happened. Let us say this is I1 current. So I1 current, and what is this current? I minus I1. How to get this one? Let's see, guys, here we have a 4 rupees. We have a 4 rupees. We spend 2 rupees. The spending is I1. And what is the remaining? So let us say this is 4 is I. So what is the remaining? So we get remaining 4 minus 2. Such a way. So what is I value? 4 minus what is 2 value? 2. So I minus I1. So such a way we have to get this. Next comes here. So come this is I1, and come to here, this is also I. So I hope current division is over. Once current division is over, our task is very simple. Our task is very simple, guys. Our task is very simple. So let's see, guys, here. Our task is very simple. So 1 ohm, 3 ohms, 4 ohms, 5 ohms. Now let's see, guys, here. Let's see 3 ohms and 4 ohms. What is the current? I1, I1 only. So what is the meaning of it? What is the meaning of it, guys? It is in series. It is in series. So now I want to change here plus to minus. So this is 1 ohm resistor. This is we have a 2 ohm resistor. Total I have to merge. So total I have to merge as one resistor. So this is also 5 ohm resistor. So this is how much, guys? 3 ohms plus 4 ohm. So 3 ohm plus 4 ohm, how much we get? 7 ohms we get. 7 ohm resistor we get. So this is the second step. So I go with the third step. So third step. So this is the first step. Step 1. This is what, guys? Second step. Let us say this is the third step. So in the third step, what you have to do? Very simple. We have to do with that. Now let's see, guys, here. These two, what is the manner? Once again. Once again. So this is I, guys. Let us say this is I1, and this is I minus I1. So what is the meaning of it? So it have a current of I minus I1, which means these two are different currents. These two have different currents. So 2 ohms and 7 ohms are two different currents which you have it. So 2 ohms and 7 ohms have two different currents. So when we have two different currents, so then what you call it as both in parallel. So both in parallel. So when you have a parallel, guys, once again 1 ohm, and we have to simplify these two. I want to simplify these two. So when you have to simplify 2 and 7 ohm, which is in parallel, just now I told one formula. R equivalent is equal to R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. According to that, 2 into 7 by 2 plus 7. So 2 into 7 how much, guys? 14. 2 plus 7 9. So 14 by 9 ohms we get. So 14 by 9 ohms we get. So 14 by 9 means what? This entire circuit can I do like this? This is 14 by 9 ohms, and we have a 5 ohm resistors with us. So 5 ohm resistors. So 1 ohm, 14 by 9 ohms and 5 ohms. So we have it. So what is the final task here? 1 ohm for 14 by 9 ohm and 5 ohms. Now let's see the current here. I is the current. Here also what guys? I only. Here also current is what? I only. So here also how much? I only. So that incoming current I is equal to outgoing current I. That is the meaning of it. So current is constant. When current is constant, what you have to do guys? So when current is constant, simple logic, the resistors are connected in series. So now what you have to do? R equivalent is equal to 1 ohm plus 14 by 9 ohm plus 5 ohm. 14 by 9 ohm plus 5 ohm. So 1 plus 5 6, 6 plus 14 by 9, 6 plus 14 by 9. So what you get? 9 6 are 54, 54 plus 14 by 9. So it's nothing but 68 by 9 ohms. So 68 by 9 ohms. So this is the what exactly you get. The total resistance of this entire circuit is 68 by 9 ohms. So 68 by 9 ohms is the total resistance. Will exactly have this. Will exactly have this circuit. Let's see another circuit. I hope people are understood. So is there any query? Please comment. Please comment, and we have to respond for that comments. I hope. See the next one. So next you go with. I want to find the current also. Sometimes I need current also. I want to calculate current value also. I need. So how to tackle at that situations? I want to tackle that situations. So let's see guys here. I want to tackle. So let's say one example I quoted. A very beautiful example, many times asked in many examinations, competitive examination generally. So I am taking two resistors. I connected with a resistor. I am taking a battery. I don't know the battery value, that is E. And this resistor is let us say 5 ohm. 5 ohm resistor, this one. This is a 2 ohm resistor. This is 4 ohm resistor. And this is 6 ohm resistors. And current is drawing is 2 ampere current. So this is only the circuit is given. Very, very important method. So first question is that total current. I want total current first. I want total current first. Second one is that total resistance I want. Total resistance I want. Third thing is that third thing is that I want E value also. Find E value. So these three questions I want the values. So now how to operate this one? So now how to operate this one? So I want a total current value. I want total resistance. I want E value. E value nothing but battery EMF I want. So how to tackle this one? So let's see guys here. Sorry. Let's see guys here. So these two ohms parallel to 4 ohms. Understood? Why? Because we have to take a current division. Once again, take a current division. This is I. Once I enter into here, this is I1 and this is I2. Once again, we have to apply the Kirchhoff KCL. We get I. So incoming current is equal to outgoing current, no doubt. So the question is that here, what is the relation between 2 ohms and 4 ohms? That is very, very important, guys. 2 ohms and 4 ohms. So 2 ohms and 4 ohms have different currents. So when you have a different currents in circuit, obviously both the resistors are connected in which format? So the resistors is connected in which format is nothing but what guys? That is in parallel only. So when the two resistors are parallel, the potential drop at the resistors, potential drop at resistors are equal. Keep in mind, very very important. When when current passing through respect to circuits, respect to resistors, the resistors in parallel. So what is the meaning of it? What is the meaning of it? So both having the same potential drop. That is very very important, guys. So we have a same potential drop. V1 is equal to V2. So V1 is equal to V2. So I tell you already V formula. V is equal to IR. Now we